Everyone. Hi dear students. Yeah, welcome to Sri Chaitanya Bridge classes. How are you guys? I was missing you all yesterday. It was Sunday, so we couldn't take the class, but really I was missing you. How are you? Doing good? Yeah. Fine. Yes, Namaste Dheeraj. Hi, good evening. Nagasai Ishwar Reddy. Hope dear students, all of you are working well and the concepts yes, thank you, I'm fine. Yeah. So, you remember all the concepts that we have revised so far, and the next classes also are going to be very interesting. Right, coming to today's session dear students. Before that, all of you come to math class part. Hi. Yeah, non-negative. Text all of you, non-negative. Number is the ruler of the universe. Yes, Sai Satvik, you are correct. Yeah. Suchandra. Hi Suchandra, nice name you have got, Suchandra. Non-negative. Yes, number. The entire math is based on number itself. Okay, fine. After that, dear students, in math there are greatest inventions, and one of the inventions changed the style of studying math. That is today's lecture, set theory. I think you know the man who introduced set theory is George Cantor. George Cantor was the mathematician who introduced set theory. Okay, Cantor, when introduced set theory, all of the mathematicians laughed at him. Arey yaar, what is this? It is not at all math, union, intersection. Math means there must be addition, subtraction kind of. But his introduction of set theory is a revolutionary one which changed the style of study of math. Yes, such an important set theory it is. Nowadays almost every branch of mathematics it is studied with the help of set theory. Even statistics, data science, everything, right? So once all of you please text George Cantor. Cantor, but you have to pronounce it as Cantor. Yes, all of you please text George Cantor. I love this mathematician a lot. So whose introduction is really great to be here, George Cantor. Cantor. George Cantor. Yes, George Cantor. Fine, thank you very much guys. Now in 11th class also the first topic will be set theory. The students who are new to set theory, I am going to give you the basic terminology and basic operation related to sets, followed by Cartesian product, relation. These are the contents which we are going to introduce in today's lecture. Chalo, first point, what is definition of a set? What is a set? Okay, right, everyone show your energy in the class. Let us gear up. All of you show your energy. Yes, ready everyone? Ready to listen to the lecture? Text, yes sir. I'd like to see your energy, come on. Yeah, it's there in NCERT. You see, this is a topic we can say which we will be using in every topic directly or indirectly. Such an important topic is this. Okay, so without set theory we cannot imagine the latest math. So this you can find its link, its connection, its concept will be there in each and every chapter. Okay, right everyone, thank you. Yeah, so definition of a set. A set is superb designed. A set is a well-defined collection of objects. Arey yaar, collection of, we talk about many collections in our daily life. Collection of books which we study in a particular year, collection of pens what I like, collection of people who study math. These are many collections we talk in our daily life, but certain collections are well defined. What do you mean by well defined collection? The phrase well defined collection in the sense, yeah, fine Harshita, thank you. So a collection is a well defined. If we are able to give a name to the particular collection, we are able to define the collection in a proper way such that if somebody brings some object, one must be able to specify whether that object belongs to that collection or not. For example, let me talk about two collections. Collection of all intelligent students of a class or collection of all good students in a class. Collection of all students whose percentage is greater than or equal to 90%. Two things you see. You see, suppose in a class I asked, please stand up those students who got 90 or above percent in your 10th grade. If I say this is very clear, you can say the corresponding sets will be, corresponding students will stand. Suppose if I say, students please stand up those who are all good, everybody will be standing. A student who is good with respect to A may not be good with respect to B, right? Because the word good, yeah, Hemant, fine, thank you. The word good is a relative word. It is a qualitative word which is not well defined. It varies with person to person, right? So this is not a well defined collection. This is a well defined collection. Got my point, dear students? Because a collection is said to be well defined, we must be able to give name to that collection in such a way that anyone must be able to specify whether some object belongs to that collection or not. Such collections are called well defined collections. Such well defined collections are, we call sets. So whereas this is not mathematically a set. Got it, everyone? So a set is a well defined collection. Please text all of you. Well defined collection. Please text all of you. It's an important phrase. All of you please text. Please text well defined collection. It's very, very important. Very, very important phrase. Everyone must note it. A set is a well defined collection. Well defined collection. Well defined collection. Well defined means, so it must be very specific. Like the collections, all handsome boys, all intelligent students, all beautiful monuments. These are all not well defined because they are defined with respect to certain qualitative words and all. Okay, fine. Chalo, thank you very much. Next, that's what I have written here. Then here you see the objects in the collection are called elements or members of the collection, and generally sets are denoted by capital letters, whereas elements are denoted by lowercase letters. For example, if I take the collection of all prime numbers less than 10, you see 2, 3, 5, 7, that's it. I take like this. So these are this form. This is a well defined collection. This is a set. Generally we write like A is equal to like this. Okay, right everyone? Clear this point? Clear everyone? Now, so representation of a set, dear student. You know, in daily life, in math already you know certain sets are very familiar. Set of all natural numbers is N. Set of all whole numbers is W. Set of all integers is Z. Set of all rational numbers is Q. Set of all real numbers is R. Of course, we define later, okay, set of all complex numbers we define later is C. These are very familiar collections, you know well. Next, dear students, representation of a set. A set generally can be represented in two ways. So, set one is roster form, other is set builder form. So, a set is represented in how many forms? Please let me know. A set can be represented in how many forms? 2 forms. One is roster form, second one is set builder form. Roster form, set builder form. What is roster form? You know, just now I have written set of all prime numbers, set of all prime numbers less than 10. I have written like A is equal to set of prime numbers, you see, 2, 3, 5, 7. The same set you can also write like set of all x such that x is a prime number, prime less than 10. I can write. Both are the same set, in fact. Both are the same, whereas one is like roster means I have written all the entries separated by commas, whereas second I have written the property that the elements of the set must satisfy. Got it, everyone? So, the elements of A must satisfy the condition like x. What is the property it must satisfy? It must be a prime number but less than 10. Got it? The first one is called roster form, second one is called set builder form or definition form. Okay, and another important here, in roster form elements can be written in any format, any order. So 5 you can write first. It is not necessary that small numbers must be written first. You can write in any order, and we no need to repeat the element. Suppose 3 you can write once, it is enough. You no need to write 3, 4, 5 times. Got it? Got it, everyone? What is roster form and set builder form? Clear, everyone? Clear? Clear? Yeah, fine. Okay. Next, you see guys, here you see roster form we list like this, and set builder form we define the set through its property. That is the major difference, boys. Now you see, try to answer this question, everyone. Which of the following is the correct set builder form for 4, 5, 6, 7, 8? This is the set. This is the set. So which option is correct? You see, 4, 5, 6, 7, 8. All of you try to answer. Come on. Come on. So first option or second option, third or fourth? Yeah, come on. Yes, very clear. X is a natural number. 4, 5, 6, 7, 8 means it is more than 3, less than 9. Option 3 is the right answer. Very nice. Super, super. Very good. That means you understand the point what set builder form is. Super. Good, 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 good. Next, you see, which of the following is the correct roster form for the set of all the letters of the word representation? Try this. Please try this. Representation means I have to write in roster form. Do remember, when you are writing a set in roster form, you can write the letters in any order, but generally any letter we write only once. You see, R, E, P, second R you no need to write, second E no need to write, yes, this E no need to write, N, T, A, this T not required, I OK, this O OK, N is already written. You see, you got R, E, P, then S, N, T, A, I, O. These are the letters. You just see, dear boys and girls, R, E, P, S, N, T, A, I, O. R, E, P, S, you see, here E repeated twice, this is not the answer. E repeated twice, this is not the answer. R, E, P, S, N, T, A, I, O. And here N is repeated again, so this is not the answer. Fourth option you can go with, right? Clear, everyone? Very easy, right? Very easy, very easy. writing a set in set builder form. So dear students, a set is a collection of well defined objects. Point number 1, a set is denoted by capital letters, and then the members of the set are called elements of the set. Generally sets are denoted by capital letters. Fine. And another important point before that, you see this is a set, suppose, or else you take this set, you see this set or this set, suppose B is set of 4, 5, 6, 7, 8. I'd like to write, you see, number 6 belongs to this set. I write 6 belongs to B. Instead of writing lengthy, you see, mathematics is language of science. You know, we are lazy. We don't want to write lengthy sentences. We want to write the lengthy sentence like 6 belong to the set B. This is the symbol, 6 belongs to B. You see, 9 does not belong to B. So you can write like 9 does not belong to B. This notation is important. This notation is important. Okay. So belongs to, does not belong to is also important. Okay. Right. So after this, I am going to discuss about the terminology related to set theory, the most important terminology. Before that, dear students, what did we discuss so far? Point number 1, what is a set? A set is a well defined collection of objects. A set can be represented in two ways: roster form, set builder form. Roster form in the sense just listing out the elements separated by commas. Set builder form means we write with respect to the property what the elements satisfy. Next, while writing a set in roster form, you can write in any order and you no need to repeat the elements. Belongs to notation is also important. Set builder form means we write like X such that, Y such that, like that it will be. Okay, right? The next, dear students, we are going to discuss terminology related to set theory. Around 8 important definitions I am going to give. Before that, everyone, all of you, just stay tuned to the class. All of you give thumbs up, like, all of you give thumbs up and like. Those who didn't subscribe the channel, subscribe. So many students are watching the session, but you didn't like the session. Like it, subscribe it, all of you, come on. Okay. Right, everyone? Yes. Very good, very good, very good. Nice, nice. Now, you see terminology. Here, you see first new term here is empty set. A set having no elements is called an empty set. A set having no elements is called an empty set. For example, set of all prime numbers less than 2. It won't have any elements. We simply write like this. This is a set having no elements, right? So empty set, which is also denoted by phi, or phi we call R. You can say phi or phi, both are okay, but correct pronunciation is phi. This is right, this is the one, empty set. Nothing is there means, suppose, can I write empty set like this? Because nothing is there, can I write 0? Can I write 0? Is this correct notation for empty set? Is this correct notation for empty set? All of you please respond yes or no. Is this empty set or not? Yes or no? No, it is not empty set. It is a set having an element called 0. So be careful. Nothing means you don't feel like 0 is there in that. So empty set. Okay. Finite set means a set is said to be finite if it is either empty set or it has finite number of elements. A set is said to be finite if it is either empty set or it is having finite number of elements. For example, you see set of all natural numbers less than 30. So you can write 1, 2, 3 and so on 29. This is a finite set. Set of all prime numbers less than 1 crore. It's a finite set. Set of all integers between 4 and 40 is a finite set. Okay, finite set means a set is having finite number of elements. Even empty set is also read as a finite set. Whereas, dear students, infinite set is that which is not a finite set. Infinite set means not a finite set, not a finite set. For example, set of natural numbers is a infinite set. Set of whole numbers is an infinite set. Set of integers, set of, you can say, prime numbers, all these are, all these are infinite sets, right? Clear? Fine. The next point, cardinal number of a finite set. For example, you have taken a set called A is equal to set 5, 8, 9, 11. You see, this set is having 4 elements. This set is having 4 elements. We write like n of A is equal to 4. This n of A is equal to 4 means number of elements in the set. Number of elements in the set is called cardinal number or order of the set. We just write like, if A is the set, we write like n of A is equal to whatever number it is there, we write like this. Okay. Yeah. Next, singleton set means singleton set. A set having only one element is called a singleton set. A set having only one element is called singleton set. For example, set of all even prime numbers. We can write like this. Don't read it as set of 2, you must read it as singleton 2. Singleton 2 means itself a set. Singleton 2 means itself a set having one element. Okay, singleton 2. Fine. Okay, right. Next, the next, universal set, generally denoted by mu, which contains all the entries of the context what we are discussing about. Suppose I am talking about students who performed well, who performed, then the percentages performance I am going to study. Set of all students of the school can be taken as universal set, or set of all students of the concerned board can be taken as universal set. Generally, in a particular problem, he will mention what is universal set. Accordingly, we see universal set is that set which contains all the entries. Got it, everyone? Clear? The time is exactly 17:28. What is the speciality of this number 17:28? Can anyone? 17:28. Can anyone say what is the speciality? In my earlier class I told, how many of you following me seriously? Let me see. 17:28. What is this number speciality? Yashwant, 17:28 number speciality cheppura nanna. Okay, very good. Dr. Tulsi Krishna. Yes, very good. 17:28 is 12 cube. 12 cube. 12 cube. Wonderful. 12 cube. Beautiful. You have to remember it. This is helpful in certain calculations. Okay. If you just wait couple of seconds, you will get one more beautiful number. What is that? One more beautiful number. What is that? 1729. I am waiting for that on the screen. I got 1729. What is this number? 1729. Come on. 1729. So it is just one more than 12 cube. It is Ramanujan number. This is the smallest number which can be written as sum of two cubes in two ways. 12 cube plus 1 cube and 9 cube plus 10 cube. Right? Correct. Ramanujan number. Wonderful, dear students. I really love the interest that you have. Oh, it is not 43 square. No. Not 43 square, beta. Okay. So this is not a perfect square, but Ramanujan number, 12 cube plus 1 cube. Yeah. Right, fine. After this, boys, universal set is that equivalent sets means two sets are said to be equivalent if they have equal number of elements. Two finite sets are said to be Two finites are said to be equivalent if they have finite number of elements. For example, A is say set 1, 2, 3, 4 and B is set L, M, N, R something. So, both the sets are having 4 elements and hence you see you can say n of A is equal to n of B. We say that they are equivalent sets. We write A tirla B. A tirla B means they are equivalent sets. Got it everyone? Equivalent sets means the finite sets having same number of elements. Next part is equal sets. In fact, equal sets are nothing but the sets having same elements. Same elements. For example, if I write a set P is equal to set of all x such that x is a natural number, x less than 5, I have written. They seem to be different, they are written in different language, but in fact both will have same elements. So we can say, dear students, A is equal to P. A is equal to P. In fact, same elements. Okay, everyone? Got it? So, once again, what did we discuss so far? A set is a well-defined collection of objects. Objects are called elements. Set is generally denoted by capital letters and the objects or elements are denoted by lowercase letters. Belongs to notation, does not belong to notation. After that, a set can be represented in two ways, roster form, set builder form. You have seen how to write the conditions and all. After that, few more terms related to set theory. One is empty set, a set having no elements. Finite set, either empty set or a set having finite number of elements. Infinite set, which is not a finite set. Cardinal number means order of the set, that means number of elements of the set. Singleton set having only one element. Universal set, a set having all the elements of the context. Equivalent sets, two finite sets are said to be equivalent if they have same number of elements, and equal sets in fact same sets. Got it everyone? Those who understand, yes, give a thumbs up and like, give a thumbs up. Those who are watching seriously, just let me show your seriousness here. Give a thumbs up and like, subscribe to the channel, like it. Quick. We need to discuss a lot. Come on. Right. Thank you very much. That's great. Fine. Lovely. Subset. Next concept is subset, dear students. Suppose A is set 1, 3, 5, 7. Suppose B is another set having elements like 1, 2, 3, 5, 8, 9, 10, 7. Okay. Here, dear students, A is a set, B is a set where every element of A is there in B. You see, 1 is there, 3 is there, 5 is there, 7 is there. If every element of A is in B, okay, sometimes buffering, okay. If every element of A is an element of B, we write like A subset of B, this symbol, or sometimes we simply write A subset of B. Both are the same. Nothing wrong in that. Both are the same. Got it everyone? A subset of B. Is it clear? So Kaushal, intelligent people is a finite set. It is not at all a set. Intelligent is not a well-defined term. Okay. Intelligent is not a well-defined term and hence it is not at all a set. Finite, infinite, next thing. Okay. Fine, chalo. So A subset of B. Let me take C is equal to set of 2, 1, 3, 7, 9, 11. You see, can I say that A subset of C? 1 is there, 3 is there, 7 is there, but 5 is not there. One element of A is not there in C, so you shouldn't say A is not subset of C. A is not subset of C. Okay, right? Subset means completely, and Venn diagrams are the diagrams which help us to understand if A is subset of B, you can write suppose A is a set which is subset of B. You see, A is completely inside of B. This is what we call A subset of B. Okay, yeah. Whereas you see A is not completely subset of C. That diagram you can write like A is here, C is having some elements common with A but not all. So A and C can be drawn like this. Venn diagrams are definitely the diagrams which help us to understand sets, position and all. Okay. Next, dear students, before we go to complement, here I'd like to talk about number of subsets. Suppose A is set 1, 2, 3. A is set 1, 2, 3. How many subsets this set will have? Number of subsets of A. Come on, dear students, let me know number of subsets. Arey yaar, these many students are watching but you didn't like the video. Why? Come on, like the video, subscribe, add energy to the class, add energy. Yes, many didn't like the video. Like it everyone. Right, chalo. A is set 1, 2, 3. Now my question is, how many subsets will this set have? Yes, thank you very much, boys and girls. Thank you very much. A is set 1, 2, 3. Now how many subsets will have? You see, let me list out all the subsets. Singleton 1, singleton 2 is a subset, singleton 3, set 1, 2, set 1, 3, set 2, 3, set 1, 2, 3. Okay, and even empty set is also a subset. Do remember, every set is subset of itself and empty set is always subset of any set. Okay, so with this combination, if you observe, dear students, there will be 8 subsets. There will be 8 subsets. In fact, subset means selecting these elements. Those who know a little bit of permutations, every element has 2 possibilities. It may be taken, may not be taken. 2 also may be taken, may not be taken. T also may be taken, may not be taken. 2 into 2 into 2, 2 cube subsets you will get. Okay, 2 cube subsets. Suppose it is having 5 elements, 2 into 2 into 2 into 2, 5 times 2 power 5. It is having suppose n elements, total number of subsets will be 2 power n. Clear everyone? Total number of subsets formula 2 power n, correct? Number of suppose n of A is n, suppose total number of subsets is going to be 2 power n. Suppose if somebody asks number of proper subsets. Proper subset is that subset which contain less number of elements than the given set. Except this, all are proper subsets. Except this, all are proper subsets. In that case, number of proper subsets is going to be 2 power n minus 1. 2 power n minus 1. Okay, yeah. So another point, power set. For the set A, power set of A means it is a new set having all the subsets as a set. You see the definitions in this particular page, I try to give, for a set how many subsets will be, total number of subsets, number of proper subsets, power set. I have given 3 definitions here. Clear everyone? Clear? Actually, subset is a very big discussion where you can have lot many questions. Number of subsets having only 2 elements, number of subsets which contain 2 but not 3. Many a combination questions can be framed, that we will see in the class. There we will discuss, right? Yeah, set of all subsets of a given set is called power set of the given set, Right everyone? Right everyone? Clear? Then, yeah, complement of a set and Venn diagram. Complement of a set in the sense, yeah, suppose A is set 1, 3, 5. In this context, suppose mu is 1, 2, 3, 4, 5, 6, 7, suppose. Now, dear students, A complement or A dash we write. What do you mean by A complement or A dash? It's very simple. So, from mu you remove the elements of A, you will get 2, 4, 6, 7. This is called A complement or A dash, dear students. A complement or A dash. Okay. From total, in fact, universal set, you have to remove A. This is what we call, dear students, A complement. And you can, like in matrices A transpose whole transpose, A complement whole complement will become A. A complement whole complement will become A. Clear everyone? Right? So, Venn diagrams I already told you. To understand we can draw something. Yeah, we'll go to then operations of set, which are the most important part of the sets. So, right everyone? So far I have given the terminology of set theory, right? Terminology of set theory. Now we are going to do operations or sets, especially union of sets, intersection of sets, difference, symmetry difference. Okay, right everyone? Clear? Right? Now, union of sets means, all of you listen to me, this is very, very simple and important, very easy and very, very simple also. Suppose, dear students, A is 1, 2, 3, 4, 5, some set. B is say some 3, 4, 5, 6, 7, 8. Okay. Now, we define A union B. Listen to me. We define A union B, okay, as set of all elements which belongs to either A or B. Either A or B. That means you combine all the elements 1, 2, 3, 4, 5, 6, 7, 8. The elements 3, 4, 5 are there in both. You write only once, you will get A union B. Clear? A union B, how to write? Do you all understand how to write union of two sets? Simple, combine. Union means combine both the sets. Clear everyone? And can somebody say what will be B union A? B union A. Is it the same? B union A. Is it the same? Yes or no? Yes. Combining only, no. A union B, B union A will be the same. And to understand by diagram, suppose this is universal set. A is a set here, B is a set here. A union B in the sense, A union B comprises of, you have to combine the total area covered by A as well as B, and so no area is left. Clear? This is A union B. Am I correct everyone? Am I correct? Do you understand how to find A union B? How to find A union B? Do you understand? Yes? Yeah, nice, nice, nice. Very good, very good. Okay. Next, similarly, so dear students, union of sets in the sense simple, A union B is defined as set of all x such that x is in A or x is in B. If x belongs to A or B can be taken and can be gathered like A union B. Right everyone? Then next we will go to the next point, intersection of two sets. Intersection. This is the word itself, I think you can understand. Suppose A is 1, 2, 3, 4, 5, 6, some set. B is say some 3, 4, 5, 6, 7, 8, 9. Dear students, A intersection B stands for the common elements. A intersection B, yeah, intersection means common. Common elements of both the sets must be listed. Just list out, dear students. So 1, 2, 3. So what are the common elements? 3, 4, 5, 6. 3, 4, 5, 6 are the common. You can write 3, 4, 5, 6 here. That's it. Intersection gives the common elements. Am I correct? Intersection is common elements. And what can you say about B intersection A? B intersection A. B intersection A is nothing but, yeah, again the same, no change. A intersection B, B intersection A are the same. For example, dear students, you might have heard about the point of intersection of two lines. This is line 1, this is line 2. This is set of all points of first line L1. This is set of all points of line L2. If they intersect at one point, L1 intersection L2 is, suppose this point is A, we write like A. If two lines are parallel, say L1, L2, they have no points of intersection. We write L1 intersection L2 is equal to empty. So there is no intersection. Dear students, if two lines have or two sets have no intersection, they are called disjoint sets. Please do remember, disjoint sets. Please all of you text, is very important one. All of you text disjoint sets. Come on, text disjoint sets. What do you mean disjoint sets? Disjoint sets. Text disjoint sets. Disjoint sets. Arey yaar, many of you didn't like the video, didn't subscribe. Come on, do it. Do it. You didn't like it. Yeah. Like the video, subscribe. Okay. Add energy to the class. Video will be forwarded to many of your friends. More will join. Come on. Right. Arey yaar. Yeah, I Tulsi Krishna, right, okay. Yeah, I mean to say, everyone, all of you don't leave the class. A very important point I am going to give you. 13 minutes are left. I am going to cover at least 13 new points. Be here. Stay connected. Okay, right. So disjoint sets. Yeah. Disjoint sets in the sense, the sets having no common elements. Okay, now dear students, coming to Venn diagrams, actually A intersection B can be defined as set of all x such that x belongs to A and x belongs to B, whereas A union B is x belongs to A or x belongs to B. Here x belongs to A and x belongs to B. If you want to talk about Venn diagram, you see this is A, this is B. So what do you mean by A intersection B? Come on, A intersection B. What do you mean by A intersection B? You can, the most common area to A and B is A intersection B. Okay, A intersection B, right? Most common area to A and B is A intersection B. Okay, right? Yeah. Fine. And if the sets are disjoint, you can write like A and B like this. There is no common to A and B, they are disjoint sets. Disjoint sets are very important. Disjoint sets are very important. Okay, right. Next, the next one is difference of sets. What do you mean by difference of sets? It's very simple. Difference of sets in the sense, suppose A is set 1, 2, 3, 4, 5, 6. Say B is set of 4, 5, 6, 7, 8, suppose. Right, everyone? You just write A minus B. A minus B means many students will have a lot of confusion here. From A, you are removing the elements of B. From A, you are remove the elements of B. So after that, whatever elements are left in A, that you have to write. For example, here From A, remove 4 is there, you remove 4, 5, 6. After that 1, 2, 3 are left in A. This is A minus B. Okay, got it everyone? Got it? A minus B. Now try to say B minus A, all of you. B minus A. Come on, B minus A. Come on, let me know the answer. Everyone please. B minus A. From B you subtract A. Come on. From B if you subtract A, 1 is to be removed, 2, 3, 4, 5, 6 are to be removed. You are left with 7, 8. This is B minus A. Wonderful. Super dear students. Super, super. Very good. Very good. So, A minus B, B minus A should be done. Observe that A minus B, B minus A need not be same. Need not be same. Correct? Yeah. Chalo. Now, coming to Venn diagram, if you just take A and B like two sets, A minus B means which area? From A you take out B, this area is known as A minus B. A minus B. Whereas you see B minus A means from B you take out A, you are left with this area. This is nothing but B minus A. A minus B is different, B minus A is different. Got my point? Clear? Clear? Yes. So you can also define A minus B like set of all x belongs to A and x not belongs to B. X must be belonging to A but not belonging to B. That is what A minus B is. Observe that A minus B, B minus A are almost you can say disjoint in this case. Correct? Yeah. Chalo. Then the next dear students, symmetric difference of two sets. Okay. Yeah. Symmetric difference in the sense we write like A delta B, which is nothing but A minus B union B minus A. For example, suppose A is set 1, 2, 3, 4, 5, 6. Suppose B is say 5, 6, 7, 8, 9. Suppose here you see what is A minus B? A minus B is nothing but you see you can write from take out 5, 6, 1, 2, 3, 4. B minus A is nothing but from B take out 1, 2, 3, 4, 5, 6. You are left with 7, 8, 9. You know we have done this just now. A minus B, B minus A. What you just try to combine these two. A delta B in this case. A minus B union B minus A will give you set 1, 2, 3, 4, 7, 8, 9. This is A delta B. Clear? Yeah. Clear dear students? Arey yaar, many of you didn't like my video. Today I didn't get the century likes. Why so? Like it, subscribe, encourage, participate. Okay. So, sir, can you give example of where A minus B is equal to B minus A? If A is equal to B, A minus B empty, B minus A empty. So, you can say A minus B is equal to B minus A. Clear? If A is equal to B, you just take A is equal to B. You will get A minus B is equal to B minus A. Okay? Fine. Chalo. Right? Now, dear students, for Venn diagram part, coming to Venn diagram, symmetric difference, it's a beautiful point. This is, suppose this is A, this is B. A delta B stands for, you see this is A minus B, this is B minus A. This area is A delta B. Thank you. Nice. So, 2 runs short of century. Yeah. A delta B. A delta B. A delta B. A delta B in the sense, this is the one. You see, this is A minus B union B minus A. Arey yaar, can I write this? Can I write this like? Can I write this like You see, just see this. Can I name the same like A union B minus A intersection B? Can I give? A union B minus A intersection B. Is this correct? The same, you see in the figure, A union B is total. From this I removed A intersection B, I got A delta B. So this is another definition of symmetric difference, right? Correct? So dear students, so I have given 4 important operations on sets. One is, see all of you, very important thing, those who are learning set theory for the first time, after learning the terminology of set theory, first one is union of sets. Combine all the elements of A and B. Intersection of sets, just take the common elements of A and B. Then you can say A minus B, difference. From A, remove the elements of B, correct? And B minus A also. A delta B. A delta B stands for this itself. So combine A union B. From this you take out A intersection B. Or A minus B union B minus A will become A delta B. Of course, A complement, which we have spoken earlier, this is nothing but mu minus A, difference only. From the universal set you remove A. These are the important observations. No, A delta B, what if A delta B is equal to A union B? A delta B is equal to A union B means A intersection B is empty. If you see, if the two sets are disjoint, A union B is same as A delta B, that's it. That means A intersection B is empty set. That's all, very simple. Okay, right. So actually properties we need to discuss. One important observation that you need to learn is N of A union B is equal to N of A plus N of B minus N of A intersection B. So this is principle of inclusion and exclusion, with the help of which we do wonderful problems. Of course, this will be discussed even in the class. We will have even for the 3 sets also. Okay, so Cartesian product and all we will discuss tomorrow. Today's important takeaways, dear students. All of you get ready. I am going to revise the entire topic in 2 minutes. Are you all ready? Are you all ready? I am going to revise the content that what we have discussed so far in 2 minutes. Ready, dear students? All of you text ready? Ready? We are left with only 2 minutes. Come on. Point number 1, dear students. A set is a well-defined collection of objects. A set can be represented in 2 ways, roster form, set builder form. Roster form is that we write the elements separated by commas. Set builder form is that we write like X such that X belongs to in definition format. Then generally sets are denoted by capital letters, elements are denoted by lowercase letters, and belongs to, does not belong to notation is very important. If a particular element belongs to this, we write belongs to, otherwise does not belong to. Then we have defined empty set, a set having no elements. Finite set, either empty set having finite number of elements. Infinite set, which is not a finite set. And you can also see cardinality of a set, number of elements of a set. Singleton set having only one element. Equivalent sets having same number of elements. Equal sets, that means same sets. In fact, with respect to subset, we can also say if A subset of B and B subset of A, we can say A is equal to B. The next, dear students, after that the important part is, after introducing all the types, the most important point, complement of a set. Universal set is that set having all the entries of the set. Complement of a set is mu minus A, right? The next, most importantly, we have seen operations on sets. Union, combine all the elements. Intersection, take the common elements. A minus B, from A remove the elements of B, whatever is left, that is A minus B. A delta B is A union B minus A intersection B, or A minus B union B minus A. So N of A union B will become N of A plus N of B minus N of A intersection B. That is all about set theory in 2 minutes. Got it, everyone? Fine. Yeah, thank you. That's all for the day. So tomorrow we are going to discuss Cartesian product, then relation, function, domain, range, all these things we are going to give, right? See you, bye. It's time, 6 o'clock. So chemistry sir is waiting for you. Catch you tomorrow. Take care, bye. Where is the energy, bhaiya? Okay, sir, bye. Okay. Yes, sir, super, sir. Energy, 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 energy. Okay, bye.